Thank you and thank you so much. Let's be start the another lecture about the integrating renewable energy sources into modern electrical power systems, about the challenges and how opportunities for the net zero. For example, the main campus of this presentation about the difference between the H2 and also the battery energy storage and the application when we want to meet the energy need with the renewable energy sources. The learning objective of this lecture about the understanding the challenges of the renewable integration, recognize the need for the system flexibility, explain the role of the H2 in the power systems. About first, we start with the one question: why do we need renewable energy for the electricity generation? This is the main questions of this lecture. The first main questions of this lecture. The answer. So, uh, in summary, there are few main reasons why power systems are moving toward the renewable energy. The first of all, the climate change and the net zero goals mean we must reduce emissions, and renewable energy helps produce cleaner electricity. And also the depletion of the fossil fuels, because as we know, the fossil fuels are limited, and the government must more secure about the energy sources. And also, we know that the fossil fuels also cause pollution, which harms the environment and human health. So cleaner energy is needed. And also the finally, and for example, the finally, electricity use is growing because of electric cars and heating, and this extra electricity must come from the clean and renewable energy sources. For the about the classification of the renewable energy sources for the power generation, first of all, we have the solar and wind systems. These types of the renewable energy resources depend on the weather, so their power output can change over time. But they are widely used because they are clean and easy to in, install and expand. And also we have the hydropower is a major and reliable technology that can provide a stable, large-scale electricity and help balance the grid. And also we have the bioenergy and geothermal systems offer more stable power than solar and wind, but their use is limited to specific resources and location. In general, and in conclusion, solar and wind dominate renewable electricity generation despite their valuable output. Also about this, we have it briefly take a look of the solar power technologies in the electrical power systems. First of all, we have the photovoltaic PV system converts some sunlight directly into electricity using solar panels. They are widely used in a small and large size because they are simple, flexible, and easy to install. And also we have the concentrated solar power CSP systems use mirrors or lenses to focus sunlight and produce heat. This heat is then used to generate electricity, often throughout the steam turbine. CSP, the abbreviation that, for example, for the concentrated solar power, is mainly used in large power plant and can have thermal storage. Also, we have the another idea about another types about the hybrid solar systems, combine solar power with other energy sources or storage systems. This combination helps improve reliability and ensures a more stable electricity supply when solar energy is not ready. Also, we have about the wind power technologies in the electrical power systems. As you know, we focus on the solar and the wind types of the renewable energy sources because they, for example, they are exist everywhere. But for example, about in contracts, the bioenergy and geothermal energy sources are not easy are not easy access. About the wind turbine, we have two types, onshore and offshore. About the onshore wind turbines are built on land and the most common types of the wind power. They are relatively low in cost and easier to install and maintain. For this reason, onshore wind turbine is widely used in many countries. And also we have the offshore wind turbine or installed at sea when wind speeds are usually higher and more consistent. This allows offshore wind farms to produce large amounts of electricity, making them suitable for large-scale power generation, even though they are more complex and costly. Let's have a look of the second question. Why is the integrated renewable energy challenges for the power systems? That's, for example, is a very important question that we should answer it. About for this slide, we explain the, for example, the differences between the conventional power plants and also the renewable energy sources. As shown on this slide, there are the important differences between conventional power plants and renewable energy sources. Conventional power plants are controllable and dispatchable, meaning their output can be adjusted when needed. They also provide high inertia, which helps keep the power system stable and maintain a steady frequency. But about the renewable energy sources such as wind and solar depend on weather conditions, so their power output can change over time. They also have a low inertia and limited direct control, and which make it harder to keep the power systems stable. Because of these differences, integrating large amounts of renewable energy sources requires a new solution to maintain reliability and system stability. About the challenges for the modern power system, this is the slide and very important slide that we have taken a look of the challenges for the modern power system. As renewable energy use increases, power system face three main challenges. The first one, the system stability becomes more difficult because renewable sources provide lower inertia compared to conventional power plants. The second, balancing supply and demand is harder because renewable generation such as wind and solar changes with weather condition. And also the third, system reliability must be maintained to ensure the electricity is always available for consumers. These challenges play a key role in the operation of modern power systems. So we have in this slide the solution for the grid integration. As shown on this slide, integrating large shares of the renewable energy into power system requires a high level of flexibility. The first one that we need the energy storage system play a crucial role by smoothing short-term fluctuation and maintaining real-time balance between supply and demand. The second one is the smart grid. Enhanced grid hub operation throughout advanced monitoring, control, and demand response, and also the H2 system provide a pathway for large-scale and long-term energy storage, allowing excess renewable electricity to be converted and used in the longer time period. So we have then another question. So why H2 in the modern electrical power systems? For this, we have a three answer are shown on this slide. H2 provides long-term and seasonal flexibility in the power systems. Batteries are very effective for fast and short-term balancing, such as handling hourly on daily changes in the electricity demand and renewable generation. But they are not designed to store energy for long periods of time. And also the H2 mix is possible to store large amounts of the energy and use it later over weeks and seasons. For this reason, H2 plays an important role alongside battery in supporting reliable and highly renewable power systems. Now we take a look by this flowchart about the general process for using H2 in the electrical grid. We start. For example, the electrical production is more than electrical consumption. So H2 is provided via an electrolyzer. So after that, the H2 is stored. And when the electrical production is less than electrical consumption, the H2 is fed to the fuel cell to produce electricity, and balance happens between consumption and production, and process is finished. This is, for example, the total flow chart and total process of using H2 in the electrical grid. Now let's have a briefly take a look of the electricity-based H2 production. About we take a look of the one, the most famous one, water electrolyzer using renewable electricity. We have three types of the electrolyzer. The first one, an alkaline electrolyzer, is the most established technology and is widely used because it is reliable and relatively low in cost. And also we have the PM electrolyzer can respond very quickly to changes in electricity supply, which makes them suitable for use with with variable renewable energy sources such as wind and solar. And also we have the solid oxide electrolyzer SOEC works at high temperatures and can achieve high efficiency, but it is still less major, excuse me, compared to other technologies. And also, we briefly take a look of the H2 storage option for power generation. The first one, H2, can be stored as a compressed gas, which is suitable for a small to medium amounts of storage and short-term use. And also, we have the liquid storage allows more H2 to be stored in the smaller volume, but it requires very low temperature and more energy. And also we have the underground storage such as start covers can store very large amounts of H2 for long periods of time. This type of storage is especially important for large scale and large long-term energy balancing in the power systems. Also, we take a look of the challenges of the electricity-based H2 in the power systems. That's, for example, the first one, low efficiency due to energy losses in electrolyzer, storage, and reconversion, and also high capital and infrastructure cost because of the cost of the electrolyzer, storage system, fuel cell, and grid upgrade, and also H2 storage limitation and safety concern because of the high pressure cryogenic requirement and the leakage. So we have the class activity and the decision challenge because this is a lecture, for example, for our YouTube channel. We and not a presentation in the class. We ignore it. And also we take a look of the class activity scenario setup from the power system perspective. Under what condition does H2 becomes a justified solution despite its in heavy efficiency? That, for example, in general and in briefly, in the which condition we prefer H2, for example, to the best battery energy storage. We explain it and answer this question. About the answer as shown on this slide, H2 becomes important in power system when the share of the renewable energy is very high, and the main challenge is meeting energy needs over days, weeks, or seasons. Also, H has a relatively low round-trip efficiency. It offers a level of the long-term flexibility that batteries alone cannot provide for balancing energy over long periods. So, for example, in general, that for example, if I want to briefly explain this situation, we use the H2 for the for storage in the longer period of time and using the battery energy storage in the shorter periods of time. So we have in this slide the class activity and question about which storage option fits better in each case. We have some features and you should tick which one is better for battery and which one is better for the H2. For example, very fast response in seconds, which is quite clear, is related to the battery. Suitable for short-term storage, minutes to hours, is related to the battery. Suitable for long-term storage, days and months, it is um, quite easy that is related to H2 because as you know that for example if we want to use the battery for the longer periods of time, the size of the battery is increased considerably. About the high round trip efficiency, it is quite clear that it's related to the battery because the process we only one process in the battery, charging and discharge. But for when we use the H2, we have several processes. First of all, production H2 versus the electrolyzer, then storage, and then reuse in the fuel cell. And also use for seasonal energy storage that is related to come back to the long term storage that is related to H2 and also best for the grid stability and frequency supported because in the grid we need, for example, shorter period of time. It is related to the battery and also can connect power system with other sectors, for example, industry and transport. It is related to H2. For example, we produce H2 and we can use it, for example, for production of the other byproducts such as methanol and also the fuel for um, aviation and also as a fuel in the cars and vehicles. And also you can use the answer. Key takeaways from this presentation: renewable integration is a system challenge, is quite clear. High renewable needs multi-time scale flexibility because, for example, it is the big differences between the fossil fuel power plants and renewable energy power plants because renewable energy needs more flexibility and management, and also the third key points and takeaways: batteries for the short term and H2 for the long term. Future grid rely on the smart control that, for example, I don't know, this is not, for example, the direct points of this presentation, and also net zero needs system design. Stay connected to tutoring and support. I've established and one Telegram group that we can use it, and also I have three email contacts if you need, for example, a better guideline and also, for example, better explanation. This is for the course assessment, and this is not related with this lecture. And also thank you for your attention. I hope this session gave you something to think about. Questions are welcome. Have a nice day.